The electromagnetic spectrum. The electromagnetic spectrum is the full range of electromagnetic radiation. It includes radio waves, heat and light rays, X-rays, and gamma rays. Electromagnetic radiation is a form of energy that travels at the velocity of light,
That guy looks like Ronky Chunky.
about 186,282 miles per second. As it travels, its energy switches back and forth between electric and magnetic fields. As one field increases in strength, the other decreases. The rate at which this exchange happens is called the frequency of the radiation. Different types of electromagnetic radiation have different frequencies. Radio waves have lower frequencies than light rays, for example, and blue light has a higher frequency than red. The frequency of electromagnetic radiation, measured in hertz, is the number of times in 1 second that the electrical field reaches its maximum value. Scientists say the electromagnetic radiation travels in waves. This is because the strengths of the electric and magnetic fields vary continually as they travel through space. The wavelength is the distance the wave travels and the time it takes the electric field to fall from its maximum value to its minimum value, and then rise back to its maximum value. Because of this, the wavelength is the speed of light divided by the frequency. The signal from a radio station, whose broadcast frequency is 1200 kilohertz or 1,200,000 hertz, has a wavelength of around 820 feet, for example. Radio and microwave. Radio stations broadcast using frequencies in a range from 150,000 hertz to around 20 million hertz. Each station uses a particular frequency, so receivers tune to a given station by only accepting waves at the correct frequency for that station. Land-based television transmitters send signals between 70 megahertz and 800 megahertz. 1 megahertz is 1 million hertz. Satellite TV works at even higher frequencies. These electromagnetic waves are captured by dish-shaped antennae that point toward the satellite. Radars bounce radio waves off planes, ships, and clouds to show their positions, which can be many miles away. They use wavelengths of about 1 inch. Doppler radar measures the speed of moving objects from the minute change in the frequency of the reflected waves. Microwave ovens use wavelengths of a few millimeters, which correspond to frequencies of billions of hertz. The radiation heats food by causing water molecules to vibrate. Infrared light and beyond. Infrared radiation has frequencies just lower than those of visible light. Its wavelength ranges from 1 millimeter to 750 nanometers. A nanometer or 1 nanometer is 1 billionth of a meter, or 1/25 millionth of an inch. Hot objects give off infrared radiation, which is felt as heat. Visible light is the tiny part of the electromagnetic spectrum that human eyes can see. The spectrum of colors stretches from red light at 770 nanometers to violet light at 400 nanometers. The energy of electromagnetic radiation increases as the wavelength becomes shorter. Invisible ultraviolet rays cause sunburn and have shorter wavelengths, 100 to 400 nanometers, than visible light. X-rays have even shorter wavelengths, usually less than the diameter of an atom. They penetrate flesh and bone. Gamma rays have enormous energy and can be used to produce images of cracks deep inside pieces of metal. Cellular telephones send and receive very high frequency radio signals. Wavelength is the distance between two neighboring peaks of an electromagnetic wave. An electromagnetic wave is a combination of electric and magnetic fields that vibrate in planes at right angles to one another.
Daddy.
The electromagnetic spectrum stretches from radio waves at the lowest frequencies to gamma rays at the highest frequencies. Visible light occupies a narrow range of frequencies in the middle of the electromagnetic spectrum. The wavelength variations in this artwork are not to scale. The electrons of an atom move around its nucleus in orbits. The energy of each electron depends on its orbit. Energy can make an electron jump from its usual orbit to an orbit with higher energy. When this happens, the atom takes in radiation of energy that matches the energy gap between the two orbits. The atom gives off radiation if an electron falls from a high energy orbit to a lower one. Many aircraft radar systems bounce radio waves off clouds in the flight path ahead of the aircraft. A computer analyzes the echoes to reveal the size and distance of clouds. The computer can also identify potential hazards, such as icy hailstorms. A hospital X-ray machine uses an X-ray tube to produce X-rays. A heated wire emits electrons, which are accelerated by electric fields toward a metal target. The collision ejects electrons from the metal atoms. Further electrons fall into the spaces left by the ejected electrons. As they do this, the electrons lose energy in the form of X-rays.